Okay, so now we are given that if the sine of 35, this is from a past paper, the sine 35 is equals to k, determine each of the following in terms of k. So what I'm going to do first, remember, we start doing a diagram first. That's what important. We start with the diagram. So I'm going to write my diagram here. We have the sine. What are we given? The sine of 35 degrees. They say this is equal to k. So remember the k, it's same as 1. And according to the soccer tool, this is my opposite. This is my hypotenuse. Okay. So far, everything is good. What we're going to do now, we're going to say, we need to check where is the sine 35. That's in quadrant 1. So this tells you that your diagram should be in the first quadrant. So this will be my diagram, and if that's your diagram, what are you going to do? You're going to say we have the angle as 35. If this angle is 35, I'm going to write it down. This is my 35 degrees. This is my 90 degrees. What is the other angle equals to? If we use sum of angles in a quadrant, in a triangle, this will be 180. We minus 35. We minus 90. The answer that we get, we're going to put it here. So that's my 55 degrees. Always important to do it like that. So now, we have the value of y. It's given as k. We have the value of r. It's given as 1. But we don't know what is x. We need to use theorem of Pythagoras to find for that x. So this is r squared is equal to x squared plus y squared. So what is the value of r? The value of r is 1. Let's square this side. What is the value of x? Is the one that we are looking for, plus y, which is k squared. So this will be 1. We bring the k squared this side to be negative k squared, and this is equal to x squared. We square root both sides, which will give us plus or minus 1 minus k squared. It's equals to x. But look at the x values. They are all positive in first quadrant. X will be just the root 1 minus k squared. So now that you have everything, now that you have the value of x, you have the value of r, we can try and answer the question. So this will be 1 minus k squared. Look at the question. What is the question saying? If the sine of 35 is equals to k, we need to find for 2 marks. This is just 2 marks, the sine 215. Let's try and apply what we did. So we're going to say that to answer this question, we are looking for the sine of 225 degrees. You need to ask, 215, not 25, 215. You need to ask yourself, in which quadrant is the angle 215? We know that it's between 180, if this is my 90, if this is my 270, and you can see that this angle is in quadrant 3. So what is happening in quadrant 3? What is happening in quadrant 3? We just say this is the sine of, inside the bracket, 180. We need to understand what can we add to 180 to get 215. So we're going to find the difference between 180 and 215. So we say 215 minus 180, which gives us 35, which is the given angle, if you still remember. So we need to add this to 35 degrees. Then how is sine in your quadrant 3? That's what you need to ask yourself next. So we know that the sine is negative, so this will be negative the sine of 35. We already know what is sine 35. Sine 35 is k. So if we put sine 35, what is the answer there? This will be negative k. So negative k is your final answer. So to answer this question, this is just equals to minus k. But please make sure that you show all the steps, okay? Let's look at the next one. They want us to find the cos of 70. And how can we find the cos 70? So what I'm going to do is that if we check this 70, we know that the 70 is just like saying 35 is half of 70. So to answer that question, I'm going to say we are looking for cos 70. This is answer for 5.2.2. Let's write this down. This is 5.2.1. Then we're going to answer 5.2.2. So the 5.2, we are looking for the cos of 70 degrees. Look at this problem. I have cos 70 degrees. I know that I can write this as the cos of 2 into 35 degrees. Can you see that this is a double angle? So I need to choose the angle based on, remember if we talked about the options that we have when we have, if you still remember, we said that the cos of 2 theta is equal to 1 minus 2 the sine squared theta. It's also equal to 2 the cos squared of theta minus 1, which is also equal to what? It's also equal to the cos squared theta minus the sine squared theta. So we need to choose any of these identities to substitute the cos of 2 into 35. And when I'm going to choose this, I'll refer on what I have previously. I already know what is the sine 35, so it's easy for me to choose the identity that has only sine. So this guy, I'm going to write it as 1 minus 2 the sine squared of that 35, because now I know what is 35. Remember, I can rearrange this and say this is 2, put the bracket, the sine 35 everything squared. What I'm trying to say is that the sine, what I'm trying to say is that the sine squared 35 is the same as writing it in this form, the sine 35 and everything squared. That's what I'm trying to say. So these two things, they are equal. Okay, all good. So now what I'm going to do, I have this as 1 minus 2 inside the bracket. I know what is sine 35. Remember, the sine 35 was given as k. So I'm going to substitute, this will be k and this should be squared. So what is the final answer? 1 minus 2k squared. Then this is answer you're going to get your 3 marks. So let us discuss on how we're going to get this one, the last one. How are we going to get this? We can see that we have this as the cos of A multiplied by the cos of B. Then minus the sine of A times the sine of B. This is a compound angle for what? Is it for cos? This is what you need to ask yourself. Is this a compound for cos or is it a compound for sine? Look at this. We have cos A, cos B. We have cos A, cos B. It can be for sine, but it's for cos. Then what happens to the sine? The sign changes. So we can write this as the cos of 85, which is angle A. We add this to angle B, which is 25 degrees. So we can reduce that long expression to be the cos 110 degrees. If you add this to this, gives us 110. So we reduced that long expression to cos 110. But now, what we need to focus on now is how can we work the cos 110 degrees? How can we reduce this? We know that this is in quadrant 2. And in quadrant 2, we can write this as the cos of 180 degrees. We need to subtract. What can we subtract to find 110? We need to subtract 70. So now you can celebrate because you already know what is the cos of 70. You see, this is easy. So, but now remember, the cos of 180 minus 70, this is in quadrant 2. How is cos? Cos is negative. This will be negative. The cos of 70. Now you can see that, you know what? This My final answer should be negative the cos of 70, and we already know what is cos 70. Go up. Remember, we calculated the cos of 70 to be, so what I'm trying to say is that the answer that you're going to substitute is this one here. This is cos 70. So where there's cos 70, we need to put in 1 minus what? We need to put in 1 minus 2k squared. So let us quickly go and substitute that guy. So we're going to have this as minus, inside the bracket, we have 1 minus 2. It's going to be 1 minus 2k squared. So if we multiply out the bracket, this will give us positive 2k squared plus 1 as our final answer. And this is how you answer a past paper. This is how you answer a past paper. So if you liked the lesson, please make sure that you subscribe and like, and so that you don't miss the next lesson.